Okay, so welcome everyone to this Aries masterclass that we are doing under the ESP European Conference of 2021. We welcome you all, and we would like to give you the goal of this masterclass would be to introduce you to Aries so that you become familiar with our modeling framework. Also, we will introduce you to k.LAB so that you can further explore this k.LAB by yourself after this masterclass and after this training. We wanted to create a space of knowledge exchange to exchange with you how we envision this modeling of ecosystem services and also hear from you if it is useful the way we envision it with the ones you've been working with. And also to provide you venue to start future collaborations with any of you that would like to start modeling with our Aries platform. So this masterclass outline would be, first we would have a live showing demo of our k.LAB and k-modeler. Then we will explain a bit more in depth two of the models that the system currently has, model 1 of carbon and model 2 of recreation, but also showing you how you can import your own data into these existing models and train them. We will have a 15 minutes Q&A session, so any questions that you may have during these demos or the model presentations, please paste them on the chat, and we will give you space to ask them to the panelists. And then we will split into 3 different separate rooms, breakup rooms. Room 1 will be for ecosystem service community. It will be moderated by our colleague of the team, Zuzana Harmáčková. Room 2 will be for Earth observation and modeling community. And room 3 will be for the business community. So you are more than welcome when we set up this splitting of the rooms to join any of the rooms that you may prefer. And we will gather all your insights into the tool called Miro, so that then we can come back into the plenary from these breakup rooms and comment what has been mentioned at each of the rooms. You will see also at the left side of the tool that we have provided some information. You will see an info package there with some presentations, some papers, and some videos. If you would like to get more insight in any of the work that the Aries team is working. So feel free to enter this info package and just to have a look at it. And without more to say, I leave the floor to our Ferdinando Villa, who will show us the live demo of k.LAB and k-modeler.
Thank you, Marta. Thank you, everyone. It's nice to see everyone, although it would be nicer to see them in Estonia, of course. I'm going to share my screen now, which I think I remember how it's done from here, and give you a very short introduction to what Aries is today. I mean, we have done these things in the past several times, and it always looks different because Aries evolves quite fast. One of the things that whoever has seen the system before have changed for them is that we are now promoting and using the system from a web application, which obviously has enormous implications in terms of usability, because we used to be able to do that because that's the way the system is designed, but it was difficult to provide a platform for people to actually connect and use it. Now we have solved some of the issues, so we cannot promise concurrent access to 1 million people, but at the same time we start having applications and situations where we can actually run the system from the login. So you will get, I think you have instructions on how to create a login for yourself in this site called the Hub. But once you have the Hub access, you can take the 2 paths. The simplest one is to download the software, which is still something we support and we hope that people keep doing, because that is the way to use the system as a modeler and to use the system on your own machine. Or you can use Aries itself or any of its applications. Now we have a couple of things through the web, through the network. So I will just show a first idea of how the system works by using one of the network installations, the one that we maintain here at integratedmodeling.org. So you would just enter this URL and your login details and just press login. And the system will give you a choice of applications if there are applications installed and connected to your user groups. And you will choose the one you want. And now, what we have here is the General Explorer, which is basically the blank canvas where you can type and ask for anything you want. And the Aries Farsia, which is the applications we built with the UN Statistical Office, UNDP, and other partners, to propose and to make it possible for countries to do ecosystem accounting, natural capital accounting through the network. So I'll show you this first, and maybe some ideas of how applications can be built on top of the platform. So if I click on Explorer, what I get is this very simple window, which looks like a very simple map with a bar that you can use to type your requests. You have some features added here, so you see there is a temporal and a spatial resolution, and you can see if I zoom in and out, those things change. And you have a number of options, but we are not delving into any detailed explanation here. The important part is that this is basically a simple explorer where you can ask any concept that is addressed by the knowledge base that is underlying the semantic system that is Aries, and from that query that you can just type your concept or whatever you like. I just typed the elevation, which is a concept which is pretty much guaranteed to be observable all over the world. You just can click return. And you can see the machine starting to think and finding out the best possible way for this context to observe elevation, which means in our jargon, build an observation of elevation. In this case, a raster map, because we have chosen a resolution automatically, and a map that you can download. And if you're doing GIS work, this can already be useful in itself as a way to explore a large base of knowledge around the world by making observations through a network-based system. Now, before I move forward with more interesting examples, I need to mention that you should see this particular view that you're looking at as a browser, which is obviously in a browser, but it is also very similar to the regular World Wide Web in the way it operates. Because what I'm asking is a query, just like a query in Google, and instead of looking for web pages, I look for ways to observe that particular concept, which I typed, by building a model, running it, and creating an observation as the result of running that model. And obviously, if the concept is satisfied by just data, just a data set, as you just saw, this concept will be quickly observed and will return to you a data set as an observation. But the concept can be much more complicated, like in the case of ecosystem services, for example, or ecosystem accounts. And in that case, the system will build something much more complex. Now, when you connect and you create your login in our platform, the system will attribute some demonstration groups that gives you access to certain features. And those, there is no fee, nothing like that. So you will just have to confirm your choice of groups unless you're making money out of Aries. You will not have to ever have to pay a single penny. Based on the belonging to those particular groups, you will get some default choices to get the process started. And those choices can evolve with time to follow your most likely queries based on context and where you're asking, etc., or the availability of certain observables. For the time being, you will get a list that will be very much the same at the beginning for everyone. And because I'm in a group that has to do with ecosystem services, you will see things neatly divided into ecosystem service topics that with some comments and icons that tell you the state that things are in. So let's say I'm maybe going a little bit closer and choosing something much more complicated than elevation, like net value of pollination. Obviously, in order to compute something like this, the machine will not just access a data set. There are no global data sets for these specific concepts, and you may have set particular scenarios that will require this computation to be done from scratch in each different context. So when I click this, the operation from the user perspective is exactly the same. When I click on this, the system will start putting together information, like we are in Kenya, land cover type, etc. And I can look at the decisions that the artificial intelligence behind the system has made to respond to the question. So I'm asked for net value of pollination. That has required observing the occurrence of pollination insects, which in turn requires the component caused by the landscape, others caused by the weather. And each of these particular resources come from data, or it can be computed by looking up in tables or equations, etc. And you can look at this documentation, like this live documentation of the model, as basically the log of what the machine is doing in this very moment. If you go to a different place, like not in Kenya, but in Europe, for example, you can be assured that the machine will pick different data. It may even pick different methodologies depending on the situation. Aries is basically an intelligent platform where everyone who has something to say about how things are done or which data should be used in a particular context and in a particular time, etc., can provide their information the same way that people can put up a new website on the network, on the regular network. So that automatically, for the way the system is built, that new information will become a better choice. So the models will keep improving with time. The more people uses them and the more contributions are made. So there's this perspective, which is the modeling perspective, and people who are not interested in the models don't even have to go here. There is this perspective that we have looked at before, which is the perspective where you actually have the actual outputs, the observations. And you can see I have my time set between 2012 and 2019 with a yearly time step, which I set before. So the system is actually giving me the dynamic evolution in time of what I've asked for. So I already have the result for the net value of pollination in 2012, and the system is now computing all the different results for different time steps. So it will give me how not only the value at the beginning, but also how the value is changing through time. All of this is automatic. And going back for a second to this picture here, all of these pieces are part of the network. So they are not necessarily, in this case, I'm using a browser, so nothing is on my machine. But even if I was modeling on my machine, I wouldn't need to have all the data on my machine. I'd be able to provide my own data for my machine to use them if I'm using it locally, or to contribute my own data to a node, which is like a network server for the infrastructure. We could also be hosted at my own place, or it could be hosted publicly, so that other people could use it. But the spirit of this is really not the one of building some new models and making them available through the network. Obviously, that is a relevant goal for us and something that we want to enable. But it is not at all the entirety of the story. The entirety of the story is to build a subset of the World Wide Web where information is semantically annotated so that it can be seamlessly connected, and it can be contributed to by any provider who knows how to do something in a better way, so that the use of the system will, in time, create better and better models that don't need, from the user's perspective, any other interaction than just asking what the user wants. So this is happening now. You see that the time is moving on, and it takes a while because time is like 7 years of observations. This value, which is the initialization value, is the net value of pollination, meaning that if you look at each point here, it will be white, meaning 0, when the request, the demand for pollination services more or less equals the supply, so there are enough pollinators to pollinate the cultivations in that specific point. It will be red where there are cultivations that may use more pollination compared to what the system has computed is available, and green where there are more pollinations than cultivations, which is one way to look at the problem. Obviously, there are others. Now, very quickly, this is the perspective for the, let's say, the data person, for the outputs, etc. There is a perspective for the modeler, which we have discussed, and there is an interesting perspective here, which is the perspective for the decision maker, which is basically where there is the entire information about what happened in the model. And this information is divided up into a report, which is structured with figures and legends, etc., etc. And this is built by assembling different components by the artificial intelligence. So it's a report that gives you full documentation, and humans have written these particular pieces, but they haven't assembled it because the machine has made different choices, and it will assemble all the documentation for all the different pieces in a logically organized way, but putting together reports that might be different every time you run the model, and also will be sensitive to the actual outputs. So if the programmer has decided to discuss the results according to particular values, that can also be done and might be reflected in the output. It will have also references. It's not finished, so we will see it later. But it's all cross-referenced and organized.
Ferdinando, can you enlarge the window a little bit if it's possible?
I'm not sure what I can do. I'll do my best here. And okay, so maybe that's a little better. I have a very large screen, so I'm not sure how good it is to just have a very high resolution. But the other parts of this window here, the other component, these are all the data sources. And because the system picks data from the network, but keeps them accurately organized and documented, for each data set that has been used, you get a badge here, like a card, where you have the link to the actual data. So you can, if they are public, you can go and download them. If they are not, you may not have the link. And you get the descriptions and the authors, the spatial coverage of each of them. These are all global data, so you don't see anything here, but you could see like a little red polygon that tells you where the data are available. At the same time, you have all the figures in a particular view, and this is a view for tables that has nothing in this particular case because the system is, in this case, is not making any tables, but actually might. So this is more or less the story with Aries, and obviously this content that you see over here, this is not a list of models, but it's a list of concepts, and this is a key in Aries, because Aries picks a concept as a query and then will satisfy it at runtime depending on the context that you are observing that concept into. So that's why the models can be different every time, and that's why we list concepts here and not models, because these are basically keys for you to pick the model that is most correct at the time of computation for the context of your interest in the time of interest. So that's more or less where Aries is at the moment, and we have a number of models. We are also discussing with several people how to improve this model base. We are building a lot of models. For example, water models are still coming. Potential value of water supply, you see it's gray because it's coming in the near future. Quick flow, base flow, etc., etc. We are working on wildfire, a lot of different things, and but the most important part here is that you can help. So if you have ideas on how models should be made, or there are models that you are particularly interested in, obviously you should not be shy and talk to us, because it is possible not only for others to contribute models to Aries, but also for others to host models for the infrastructure. So you don't have to give the models to us in order to build up the system. It's basically a platform that we made available, and it can be used by anyone, and the information doesn't have to leave the computer or the node or the network server that can be installed by anyone else. So before I move to having a look at applications, this is our interface for modelers, and I wanted to show you very quickly, just as an example, how models are put together and the way they are written, because it's a very different way from what you may be used to. So you're probably used to Python or to R or this kind of models where you have to really procedurally implement, take the data from here, then loop over all cells or polygons, and then for each one of them calculate some things, take the data from one place, put them in another, then write back a file or something like that. There's nothing like this in Aries. Aries is a semantic system, and you can look at the model. This is our pollination model that has just been running in the background as something that looks like just the conceptual statement of a model, but it is the actual model that is running. So if you look at this, for example, this statement, model the occurrence of pollinator insects, apart from this strange notation here with the colon, which is what we use to pair it to the knowledge base. So this is basically a namespace biology and contains the word insect, or agriculture contains pollinator. These are different colors as well to give you a guide into the semantics. So pollinator is a role, insect is a subject, weather is a process. They have different colors. We don't get any more detail than this today. So the occurrence of pollinator insect is modeled by observing the occurrence of pollinator insect caused by weather and the occurrence of pollinator insect caused by the landscape. And then they are put together using this equation over here. Now, because we use concepts both for the outputs and for the inputs, all of these models are independent pieces of knowledge. They don't have to know about space, about time, about inputs, outputs, visualization, all these things, because the system takes care of all that. They just have to be conceptually correct. And it's impossible to write something, I mean, not impossible, it's difficult to write something conceptually incorrect, because the system is intelligent, so it will validate your semantics and make sure that you don't say, for example, I don't know, the length of water, something like that. Things that don't fit together conceptually. So we now have all the different data here, etc. So this is the way you write these models, and obviously there is a lot to know about this specific way of modeling, because we invented it. It took a while. It's not it's the effort of 15 to 20 years of work. But the other very important feature of this method of working is that you can put these things on the web, and they become like blueprints for the system to pick, and you have ways for the system to tell the system that this, for example, works just in Kenya, so it should not be used somewhere else. And if the system needs to know the occurrence of pollinator insect caused by weather, and it is in Romania, it will look for something else, because this is specific of Kenya, and somebody else may have put it in. So what we normally do as the Aries team is to put back to provide the system with ways of observing with global data concepts that basically work everywhere, but they may not be as accurate or as detailed as models that are ad hoc for a particular place. And then when we have a project or we have a collaboration, we add more specific models that make sure that in those particular regions or in those particular times, the models work better. But obviously it's a system that is meant for collaboration. So it's meant for people to contribute their own new ways, and no model has to substitute all the other models. You can just contextualize it to wherever that model works correctly. And that is why and how the system can improve with time. So let me go quickly to show you some applications, because one thing that is new as well is that we have now built a system that allows to build applications on top of Aries. So I will show our very latest work, which is the work we did with the United Nations. So it's now, this is running on the global platform. I don't know if you can see it, but the URL here is k.LAB officialstatistic.org, which is the global platform of the United Nations. And when I log in, I put the application I want here in the URL. I could just get the same Explorer that I got before. But if I use this link that contains the application, I will get a specific application, which in this case is meant to support natural capital accounting. And I will give just a very, because my time is not very, I don't have a lot of time available. So I will give you a short explanation. For example, there is a lot more functionality in here, because as you can see, we have menus. So instead of having the blank canvas effect, we still have the entirety of Aries here. We can do exactly the same things, but we have a menu, so we can actually choose what we want from a much simpler interface, starting from choosing our context of interest. Before you saw a square context, but you can actually go by administrative region. So this is the entirety of Kenya, or I can go in further deep into the system and get something a little smaller, like a particular part of Kenya, like this particular region over here, etc. It just goes with your zoom level, so it's very easy to pick a particular country or something else. We can also choose watersheds, etc. And then you can tell the system what you want. In this case, you may want the net balance for the ecosystem accounting. So maybe we can pick 4 years or something like that, and just click on this. And after I made my choice, the system will pick one particular account. And in this case, the account is a table. So the entirety of the semantic system still works as before. But at the end of the computation, I've asked the system to compute a table for me. And that table will contain the initial and final balance of ecosystem extent for all the different types. So in this specific application, which is meant to satisfy the SIA standard, which has been approved in March, we can ask questions about extent, which is the extension, the physical extension in area of all different types of ecosystem recognized by SIA. Condition accounts, so I can choose some metrics of condition, like NDVI, drought, severity, etc. And then I can ask for a table about the variable, the indicators, the index, according to the SIA standard. And I can go in and ask for other things like global climate regulation, sediment regulation. All of these things produce tables because in the SIA standards, the final results are tables, and those tables are required for the completion of the account. So they are compliant with the accounts. Obviously, a lot of countries already have their methodologies in place to compute these accounts, and they can keep using them, but they can also contribute their methodologies to the system, and by doing that, improve the quality of the system. More interestingly for us at the moment, there are a lot of countries who don't have a methodology in place, and now they have no excuse to build their accounts, because this system works everywhere. You can go anywhere in the world. And as you can see here, this table, which is the ecosystem type extent at the start of 2012, has been computed already here, and you can look at the different tables and the different values. I can put up something else. I don't know, maybe sediment regulation. I can click on things. I can click on more than one thing. It just queues things up. So I can look at monetary values connected to crop provision, crop pollination, carbon storage, etc. So you saw before this view here. So you have it's already computing things about the sediment. So it's the Russell factors here. They're coming because the computation is ongoing on the sediment, and this is the ecosystem extent. You can see the table here where you have all the different types of ecosystem and how much of that in the period I chose has grown or has shrunk. Maybe difficult to see. I'm a little hesitant to, and still it's computing, so you can see it changing under my eyes, but maybe I can do a little larger. So you can get all the tables here with all the different net change, etc. And normally to compute these kind of things, countries have to work a lot. They have to gather data. They have to do a lot of calculations. They have to ensure compatibility in projections, in representation, etc., etc. And then they have to actually do the calculations, which are not simple. Now, in this case, the entire difficulty of the problem has been reduced to clicking a couple of buttons, and you can do it anywhere you want. So we already have we are working with a number of countries to pilot this system, but it's already been used by several. And what you're seeing here for the SIA account can be actually provided for any other observable that is of interest in the ecosystem service community or in any other kind of spatial or non-spatial kind of accounting. So it's a pretty powerful system. So you can look at the different perspectives here. You can also look at the model perspective as before. So it's a little different in interface, the way it looks, but it actually is exactly the same functionality. And if we go back here, you can skip in computing stuff. So we have now just the table by themselves, which you can export to Excel or copy to a clipboard. You have the different figures here that keep growing and changing as new things are computed. And you have, as before, all the data sources that in this case, because we have a more complex set of observables here, you get a lot more stuff here. So that's more or less what I wanted to show you. And for example, here we have several indicators. We are actually moving towards a more comprehensive handling of the different SDGs. Obviously, there are tons of indicators there, but we are starting to build some of them. And if you click on here, you get a new menu there on the left, so that you have more buttons you can click. At this point, if I want this particular mountain green cover index, which is endorsed by the SDGs, I can just click. And as you can see, this thing spins because it's still computing the previous. When that is computed, it will also give me this computation. So you can probably get my drift here. What we have built here is not a tool for ecosystem services. Obviously, it was born with that purpose as the beginning of the story, but it is a way to treat models and data sets as if they were web pages, basically, and giving to the public an infrastructure that allows the public to provide new knowledge and to transparently observe and connect and potentially improve whatever is already on the network, just like a Wikipedia of science, although the metaphor is a little different because we obviously exert quite a bit of control on the content of all this network, because a bad apple in that network would be kind of a bad thing to have. So we try to be much more in control than the Wikipedia can be. But the spirit is the same. It's basically trying to build a collaborative information highway where all the components are known in terms of context of application and in terms of semantics, so that the links can be made and the links are guaranteed to be meaningful, so that we can provide a platform for the global community, which will eventually encompass a lot more data sources and a lot more disciplines and a lot more institutions. So we are starting now with the UN and the UNEP and a set of others, which is very encouraging to us, because this is getting under the eyes of a much bigger community now than just the ecosystem services community as it used to be. And the nice thing is that in progress in all these different communities will mean a lot of synergy, because we all talk and work on the same things. Natural capital accounting is not very different from ecosystem service analysis. I mean, it is, but they share a lot of the information, so that improving in one side will automatically improve the other. And because the machine is intelligent and can make the connections instead of relying on humans to make those connections, the improvement is automatic. We don't have to wait for somebody with a screwdriver coming in and connecting things manually. As long as things are there, the improvement is automatic, and things can be used right away and can be used to discover observations that were not made before, because the models are built by the machine. They're not just entered by humans. They are entered in their components, but the final synthesis is left to the machine. So that we are hoping that this is a year where we start really proving the usefulness of this new paradigm. So this is probably the highest level introduction that I could do. And obviously it's very, very, very high level. The purpose of this masterclass is not only to show you all the marvels of the system, but also actually to enable you to, first of all, look at the models in more details, and also enable you to actually use the system and potentially even collaborate with us, or independently provide new models, provide new data, provide new knowledge. So I will leave the floor to Ken Bagstad and Stefano Balbi for some demonstrations of models, and then we can try to have a bit of a more in detail conversation about whatever you think we should deepen, and we have more than an hour to do so. Okay, so I'll stop sharing, and I thank everybody for their attention.
Thank you very much, Ferdinando, for this demo. I see my colleagues have been of the chat, but if you have any other question, we will raise them after the live demo of the two of the models that will come now. So I will give the floor now to Ken Bagstad, Ken, who is going to explain to us the model of carbon. Ken, the floor is yours.
Thanks so much, Marta. Can everyone hear me? Great. My name is Ken Bagstad. I'm with the U.S. Geological Survey, based in the United States, and I'm a long-term collaborator with the Aries project. Are folks seeing my screen?
No, not yet.
Not yet.
Not yet. Okay, we'll give it a moment. Let's see.
Yeah, there is a model window that asks you what do you want to share. Maybe you didn't click that one. Now it's okay, man.
Your whole screen.
Okay. Now you're seeing this?
Yes.
Okay, wonderful. So yeah, thanks again. I'm going to walk through very quickly an example of a carbon model. And when we say I'm going to say a carbon model rather than the carbon model, because it's very important within Aries to point out that unlike certain types of modeling systems that you might be familiar with for ecosystem services, where choosing a particular thing to model means you're going to be directed toward one specific model for carbon or water supply or sediment regulation or anything else, Aries by design is intended to encompass multiple different types of models, different versions of the same model that could run using different parameters in different parts of the world, and that could use different data sets in different parts of the world. So I'm going to explain what we have for a global carbon model that will run anywhere in the world, but also show an example of how that can be customized. And we would really like, as the community expands and as the use of Aries expands, to be reusing other carbon models from other parts of the world, and perhaps process-based models, a wide variety of different models for the same thing. The intent in Aries is that that we choose the best model for the time and place that we're working, and also for the spatiotemporal scale that we're working at. So I'll give an example of a very simple carbon model that runs anywhere, but very important, as I said, to keep in mind that this is highly customizable and it's not hard-coded to a particular carbon model. So this example that I'm going to show is, it's very simple, but again, it's designed to run anywhere on Earth. An IPCC Tier 1 model from Russian Gibbs, and what we did was we took this model, which they had computed statically for the year 2000, and we make it able to run anywhere on Earth and to customize the inputs to it. So what this looks like is we have a huge lookup table for vegetation carbon storage based on the coefficients that they've given in this study that's mentioned up here. We take into account land cover, different types of forests and other land cover types, the region it's located in, rainforests in the tropics, temperate regions, boreal regions, etc., which continent it's located on, whether it's a frontier forest. So if we have something in the heart of the Amazon that's still, fairly undisturbed versus a more frontier or fragmented forest at the edge, where it's been, more developed, more fragmented, and that has impacts on carbon storage, whether or not a region has burned, and finally, a parameter for how many tons of carbon storage under this combination of circumstances. So it's a multi-layer lookup table. It takes as inputs all of these data sets, and it gives you a value as a result of those for vegetation carbon storage. The other thing we have, again, at the global scale is soil carbon storage data. And we have, for instance, a lot of soils parameters ranging from soil carbon storage to soil texture, soil classes, soil depth, etc. All of these are available at global scale. And what we can do is we can combine the vegetation and carbon storage together, or we could run them individually. I'm going to give a very quick example of the code just to sort of repeat what Ferdinando was describing in his introductory session, and we won't go into all the details here, but what you're going to be looking at today in the demos, it's what the user sees on the Aries Explorer side. So that's intended for use it can be used by non-technical folks or stakeholders. Doesn't require a lot of training. What goes under the hood of that is the models that are written by scientists, and the scientist specifies when and where the model should be used. So again, we have little pieces of code here. This is the entire model with the exception of the lookup table itself. And we simply say that we're modeling carbon storage in tons per hectare. And basically, we're summing vegetation carbon storage and soil carbon storage. And we have these particular inputs for that. And if someone has a better input for your part of the world than is globally available, the system will be able to automatically pick that up and to reuse that data set instead of the global one. So this is how, when we talk about interoperability of data and models and the reuse of other scientific knowledge in terms of, say, the FAIR principles, this is how Aries can do it. It can automatically detect and replace model code that points back to the same scientific observable. This second chunk of model code is the code for that carbon storage lookup table, and it's simply saying we have a list of 5 inputs here: land cover, burned land, continental region, frontier forest, and ecofloristic region. We simply query this giant lookup table and return the value from that. And so again, here's another quick look at a very small piece of that very large lookup table. I want to talk a little bit about model customization and how that works. There's lots of ways to customize. You can customize local data. So you could say, I've got a better land cover data set or a better soils data set for my part of the world. So I want to be able to use that. And again, if you can contribute that in a way that Aries can pick up, future users will be able to use it too. And the system grows and becomes more powerful for future users in that way. So one way to customize, again, is to add your own data. Another is to add your own model parameterizations. You might say that, hey, this lookup table looks great, but I've got some more recent data or some better data for my part of the world. And a final way is simply to say, I have a completely different model than this. I've got a process model for soil carbon storage in agricultural systems, for instance, and I want to substitute that entire model for the simplified version of it. And if you can get your model coded in a way that Aries can reuse, again, you can use that model and other people can reuse that model too. So really, as we talk about community, the intent there is for others to be able to very quickly reuse it. So I'll give one quick example from a study I was involved with in Rwanda. And essentially, instead of that IPCC method, we had a bunch of local data on carbon storage, and we want to be able to customize that. So we write a little bit of code. We tell Aries that when you're in this area of East Africa, you should be able to run that different model and not the global model. And so the idea is here to get you thinking as scientists about, I'm not just taking my model and putting it in a data repository or a code repository. I'm also saying these are the conditions under which you should reuse my model. Is it good for Rwanda? Is it good for all of East Africa? Is it good for particular climate zones or in cities or agricultural systems, etc.? What this looks like in practice, this is actually a very simple model. So we simply have a Rwanda-specific land cover data set coded into Aries, a Rwanda-specific lookup table, and a simple model of that lookup table where the only input is land cover, and we're saying that this can be run, that this particular model can be run for Rwanda. So if a future user goes to Rwanda, they can reuse that data instead of the global model. That's all I want to show for this, and then this is what results look like here. So we see change in carbon storage in Rwanda from 1990 to 2015, and you can see actually lots of conversion from forest to agricultural systems, so a fair bit of carbon storage loss outside of the protected areas, which and the wetlands, which are showing up as these red hotspots in 2015. So quite a bit of landscape conversion here. And the effects of that we've been able to model in Aries. That is actually all I want to show for slides. I want to take a quick look at the actual modeler interface. Are folks seeing this?
Yes, Ken.
Yes, Ken.
Yes.
Yeah, go on.
Okay.
Yes.
Wonderful. So this is, again, the same interface that Ferdinando showed, and I'll just spend a minute or two with this because Ferdinando gave a nice overview of this. But I've navigated to Estonia here, where we would all be in person in a pandemic-free world, and hopefully some of you are there enjoying it if you were able to make it. But the point is, we can go to any part of the world. We can select an administrative region, in this case Estonia. Click on a model, in this case for carbon storage, and we can get the results, which can be viewed. They can be downloaded as a GeoTIFF for future analysis. We get all the reporting features that Ferdinando showed earlier, so I won't go through all those, but the table, which we can export as an Excel file. And the last thing I'll mention about all of this is that we also have monetary valuation for certain services. Carbon storage is one of those, and that's done with social cost of carbon, which is a very simple way of valuation. Of course, you're just taking the tons of carbon sequestration or the change in carbon storage and multiplying it by a per ton value. So it's nothing fancy in terms of valuation, and you could do it on your own. But we also envision in the not too far future, we'll have what we call an interactive mode to this, where you can enter some of your own parameters, like a social cost of carbon that was used by your government, for instance, and have that be customized in the analysis. So that's really all I wanted to say, and happy to take any questions, but I think we'll wait until after Stefano's presentation to get to that. So thanks so much.
Thank you, Ken.
Thank you, Ken, for explaining the carbon model to us. And now Stefano will explain how some of you are asking, how can I use my own data?
Yeah.
How can I put some of our private data inside these models, etc., and also talk a little bit about the recreational model. Thank you, Stefano.
Yeah, perfect. So, hi everybody. Thank you for participating to this training. I am Stefano Balbi, and I coordinate the Aries team at BC3 side. So I will start by briefly discussing I was asked to present the outdoor recreation model, but at the same time, I think many people here have doubts about how to include their own data, so I will talk about that. So I pre-computed this model before, and what is important to understand with these global models is we call them globally customizable ecosystem services models because they are a template that can run everywhere in the world, but as Ken was suggesting, can also be customized for specific case studies. All of them try to represent the two sides of ecosystem services, so supply and demand. In the case of outdoor recreation, the supply side is basically the recreational features in the landscape, and this is the main output of this model for this particular region in the north of Spain around Santander. And I will explain how this is computed, but also the demand side. In this particular case, we are considering daily trips. So the idea is that people mainly resident in one place, in this case is Santander and the outskirts of Santander, will have, let's say, a distance of around 80 kilometers to go have a recreational experience and then go back. So how this model is computed, first, well, the final results, putting everything together, you see the distance from the city plays a major role, but then also the natural features are also playing the other side of the story. So how is this computed? Well, you have learned that you can click this icon here and go to the data flow. The data flow is actually quite complicated. You can zoom in and out. So, for example, this square in the middle here is the supply side. So we will consider features like water bodies, coastlines, waterways, and mountain peaks, mainly. Also the presence of protected areas. But in this part here, it's more about the demand side. So where the people is located, how far from the cities, what's the population density, and so on. So if you want to see how the things are put together, you can also click on single boxes. And in this particular case, for example, you have the function saying how supply and demand are put together. This is the report, and that is also very informative. So most of the things are explained in a narrative format here with all the references. We never invent models from scratch, almost never. So this particular model is largely inspired by the work at the JRC. And then if you want to check the code of this model, so remember that we have this piece of software called Control Center that allows you to access the engine and the modeler. The engine is basically your gateway to get connected to the semantic web of knowledge, and the modeler is the interface for modeling for modelers. We didn't explain much of the modeler, so my task here is to give you a little preview of how it can be used. So if you click after the engine, you click the modeler, then you have access to this interface. And if you import the global projects, you can check the codes for all of them. I will show in a bit how to import the project, but basically the recreation is here. If I click here, then it will open this part, and this is the entire code of the recreation model. So we have a huge part about the the supply of recreation given by natural features, like I was saying, distance to protected areas, coastline, and waterways, water bodies, mountain peaks. This is the algorithm that actually put them together. And similarly, we have for the demand side that basically considers a population density factor and the efficiency of travel, which is basically the accessibility, so the time travel to go from one place to another place. So let's imagine that, for example, we are in this particular case. A lot of the model depends on one informational layer, that is land cover type. In this particular case, this is the Corinne layer for Europe. But let's imagine I have a case study here, and I want to add my own land cover type. How do we do that? So this is what I'm teaching you in a minute. You go back to the modeler. You need to create a local project. I will create one from scratch for you. So this is the way to create a local project. You click on this icon, create and load a new k.LAB project. You give it a name. And the project is created. Now, it comes with some default, let's say, sections. I need one section to import the data layer, which is the resources. And I also will create another section for adding the semantic annotation. So imagine if I have a layer in a folder like this. This is the land cover, a TIFF file. I drag and drop it on the resources. And the system is telling me that now we have a new resource under the resources. This is the name of the file. Now I need a new namespace here to do the annotation. I can call it data, for example. And notice that you have the option to put private or not here. I will keep it private for the moment, but then I will explain why. Sorry, I did not data test. Okay, so now I have this new namespace, and I right click on the resource. I copy the URN. First, when I click on the resource, I have an editor that gives me a lot of information about the resource. For example, the geographical scope. I can add the time if I need to add time related to the resource. But anyway, what I did is to right click and copy the URN, because then in the code, I will have to write a statement to annotate semantically the resource, which is basically you start with the keywords model, you paste the URN. In this particular case, I need to add this in order to accommodate the presence of numbers and uppercase. And then I need to tell the system what is this. This is the part where we added the semantics. So in this case, it's land cover type. So in theory, this could be finished like that. The problem is every class will have a number, and the system will not know which number corresponds to which land cover class. So I actually have to finish this and do it properly. So I add the code here, and I will basically add this. I just copy and paste it to gain some time. So this is the proper way to do it. Every number in the TIFF file corresponds to a land cover class, but because every land cover class is actually a concept, I need to connect the right concept to each class. So what happens is that because the private keyword here, the reasoner, when resolving the question, what is land cover type in the case study, will not find it, because basically I'm putting this private. But if I take this away, then the system will be able to find it. Let's do an example. So I am here. I finish. I reset the context, and okay, this is done. Everything is done. I have saved. Okay, so I now here is private. Here actually is also private. Sorry, this is the example that I have prepared before. So if I search for land cover, what is going to happen is that the result will be Corinne, just like before, and you can see it from the data flow. Now let's make this experiment and change private away. I take away private. Now the system is able to see this resource. I do the same. Then over. I did this before, and it was really nice to see that basically you have two layers coming together to resolve the query. And okay, now let's say what you see now is not particularly beautiful, because you have this part from my case studies is some kind of data of land cover, and then you have the Corinne in the rest of the context. So what really needs to be done is also to work on the scale of the data itself. This is by the way, this is a case study from the Alice Interreg project, so I can put it there. This is the case study, and the land cover type is this one. Okay, now a little bit nicer. I can increase the resolution. Now I'm working at 250, for example. I can do it here. I can go, for example, at 50 meters. The data itself is at 50 meters. So, I mean, the resolution is bounded to the resolution of the data, obviously. Taking a little bit more time because now there is more data to fetch. But it will come in a second. Same as before, the land cover data with more resolution. What happens is that you can see now, it takes a little bit more time to visualize the data because the resolution is really high. You see how nice it is compared to before. But I cannot work at this resolution now because it's going to take too much time. So I will go back to 250. And what happens is I will, for example, run the value of the recreation again. And this time it will run with my local data. So what I want to stress a little bit here is that you have the opportunity to create your own project in the modeling interface. The project is local, so whatever you source, you put here, you add here, the resource will remain with you and will not be shared unless you do something like this. You click on the editor and you go to this section and click on publish. This is not available now, but basically what this will do is to push your data into a node provided by us, and this will be made available for all the users of the semantic web. But this is only an option, and it's not available at the moment. The second thing that I want to stress is that basically in every namespace, you have the possibility to work in a way that whatever resource you are using can be fetched by the system, or you can just make sure that the model is private, so it will not be used by the reasoner when resolving the concept, for example, land cover type in this particular case. Meanwhile, the model is running, and this is the output with okay, something has happened in using my own data. Something must be it doesn't like the land cover that I used, so I need to check again what's going on. Or I can just one thing that can be done is to force the observation before running the model. So you can do something like running the case study, putting the data, observing the data, and this is it. And now for example, I will run the theoretical from here. Well, I'm actually going in the recreation itself and using, for example, the theoretical value of the recreation, see what happens. But anyway, the main messages are the idea of importing data and resources, and the idea of making your resources private or public according to what you want to do. Finally, what I really want to touch on is how to import a project like Aries Global or the knowledge base. Because, for example, in this particular case, we had to do the annotation for the land cover classes. But how do you know which are the land cover classes to use? Well, I basically what I like to do is to import our knowledge base, which comes with the software when you download the software. So you do project import, project from Git, existing local repository. You add something that is in a folder under your. So under your user, basically, you will have a .k.LAB folder, and the knowledge base comes in a folder that is called the word view. This is the IM project, stands for integrated modeling. So I will import it and show you what it contains. So this is basically the model containing all the conceptual knowledge, all the ontologies, all the semantics that we use to make models interoperable. And the land cover categories, for example, that we have used are all in the land cover namespace. So, well, the first part is just for design, but then the real ontology comes at this level here, where basically you have an ontology that combines Corinne, CCI, and other land cover classifications by basically matching one concept to one or more codes in these land cover classifications. So IM is a nice project to check, and this is how you import it, and you can check the higher level knowledge for all these domains. I mean, land cover is just one of them, but you have one per every domain. Anyway, when you're looking for a concept to annotate something, I would say always start with the knowledge search here. For example, elevation. You see, you start typing and then you get a suggestion. So this is actually the first way to use the knowledge base in the system to annotate data. I think I am within the time that was given to me. Let's go back and see if yes, for example, now the theoretical value. So this is the supply side of recreation has been computed correctly using the land cover, my local land cover. I think I am done here. I'm also sorry for my voice. I'm a victim of an allergy, so I will leave the floor to my colleagues, and thank you for your attention.
Thank you, Stefano. So now you've seen the live demo of K-Explorer, K-Modeler, also a bit more in depth into some of the models, how you can insert your own data. I know most of the questions have been already addressed in the chat, but if any of you would like to take the floor, we have 10 minutes now before we break up into sessions to give you the floor and give you the microphone and turn yourself and make more questions about whatever you would like to ask. I know some of the questions were asking about the validation of your own data, if the system does validate your own data before making it public. I know the answer was already provided, but the idea is that yes, there will be a validation by by whatever validation we are usually doing for data, but not at the moment. And also there was the question on if you can add your own, let's say, private groups to work, etc. And this was already addressed also by Ken. So if any of you would like to take the floor, just raise your hand. You can place your name next to your participant list, and we will give you the floor.
Marta, I think there's been a raised hand for a long time. Marie Perron.
Okay, so Marie, we are going to give you the... Yep. Marie, you can talk now. No, she became shy, or she left. No, we cannot hear you, Marie.
Marie, have you unmuted?
You can write the question in the chat box, maybe.
Yeah.
But there are several questions in the chat box that haven't been answered. For example, from Milan, there was one on quality control. I think is super important. So the data provided by users, how there will be quality check. This is actually the question, the issue for us now. I mean, until now we have been working in an ecosystem of relatively few people, but at the moment the system has 1,500 users, and this is set to grow a lot. And also the provision of models and data is becoming a reality. One thing that I didn't say is that we will allow by the end of the year, we will allow the possibility to upload the data from the other user interface, so the K-Explorer. At least we will try. It's quite an ambitious target, but we will try, which means more and more people will try to upload their own data, and so this becomes really an important issue. So maybe Ferdinando, you want to elaborate on this a little bit? It's quite interesting.
Yeah, well, we could say a lot of things, but I think the most important thing people worry about is if I upload my data, then I lose control of them, which is never going to be the case. I mean, since the beginning, we organized the system so that data can only take the paths you decide that they can take. So in order to use your own data the way Stefano showed, you can do it on your own machine. So you download the software and data stays on your computer and it just gets used there. The ability of uploading to what we call nodes, which are machines on the infrastructure, and you can have your own node, so the node can be owned by you, and it can be on your own network and connected to the entire network. Or you can use one of ours. Well, most likely we'll make some available for people who want to use their data. Once the data are uploaded, you will have like a form where you can check which groups you want them to be available to. And obviously there will be a public button, which doesn't mean that your data are not, because as you saw, the provenance is always completely documented. So the data will not lose identity, but will be usable by others. But if you don't click that button, then the data are by default only available to you as a user, and the machine will take another path when faced with a query that could use those data. So instead of saying it works or it doesn't work according to whether you have or don't have the data, if you have access to more local data that you have provided, the machine will pick those data. But if you are not, even if you are in the same context and you don't have the access to those data, the machine will use other data from the network. So it's a paradigm that really allows completely granular control of permissions. And obviously, we don't do this for people to use their own data and not give them to anyone. So it's not that the kind of it's not the kind of usage we want to have, but it's also a kind of usage that is important, that is available. And as I was mentioning before in the chat, for us it's very important that we build some cycle of peer review within the system, so that data can start their life cycle as local data that are not seen by anyone. Then they start being public, but that is just the bottom rung of being published, where they can be available, but they have low priority, and they may have a higher priority if you own the data, even if they are public to others. And then as more people use them, and as the data prove their worth, basically their ranking in the system automatically grows. And in my opinion, this could be the beginning of a virtuous circle that actually allows, because we have fully documented provenance, etc., incentives in providing both data and models that can eventually make sure that the URL that you use to annotate the data and you get after publishing the data actually becomes like credit. It can just be associated to peer review, and it can just automatically grow in credit as the data are used more often. So it's like a publication system, but instead of having people having to cite you, which has become like a stupid game at this point, because publications are only written to be written, not to be read. There are just too many. Data are a lot more useful than that, and models are a lot more useful than that. So my hope is that eventually, instead of a URN, the way Stefano showed you, we can put a DOI in there, and that DOI is automatically associated to a process that is managed by the artificial intelligence and ranked by humans, so that the more data the data become useful, the more they grow up in recognition, both from the point of view of the documentation of your efforts and from the point of view of the artificial intelligence picking them to solve problems and to resolve observations. That's, I think, a new paradigm of looking at what to invest and what is the return for investment in developing extremely labor-intensive and expensive things like data models.
Thank you, Ferd. Mari, we can try to see if you can unmute yourself now that we've made you speaker.
Can you hear me now?
Yes, we can. Perfect.
My question was more about what Kenneth said about the documentation, because actually I was prepared for this course, and I had the k.LAB running on my computer, and I tried to upload my land use map while Stefano was showing the tips, and it's really difficult to to do so quickly, because obviously I'm not an expert, and yeah, you build this code, so obviously you know your way around. And so I was just concerned about the documentation, and if in the future it'd be possible to have a set of examples on how to import a new project and create a new project. But because I feel that this is a very simple point, just creating a new project did not work for me. So yeah, obviously, it's like Kenneth said, it's like learning an entire new TI's program, and yeah, I think it takes time, and it's obviously logical that I cannot do things in 10 minutes. So yeah.
Yeah, also it's a system that works in a completely different way from anything you've seen before. So it's not only a difficult due to the fact that the software is younger and different and complex, etc., but it's also due to the fact that it's a very new thing. So you don't have anything to compare it with. It's not like you enter your file and you use it. You enter your file and it becomes part of the knowledge base, and then it gets picked according to rules that may sound arcane, although we put a lot of thought into them. We have some material from previous training. Unfortunately, the system evolves fast, so that some parts of that material may be outdated. And we are definitely committed to do much more than that. And now we have a person who is actually listening to us, which was dedicated to communicating what we do. So we are definitely at the beginning of a lot of improvements in that sense. Still, building the system is just complicated enough. Documenting it, considering that it's also a moving target, is very complicated. So we need some patience, and we will keep doing training. Hopefully the COVID pressure will abate a little bit. And because we like having people over here and teaching them for a week or something that is actually much more productive than online. But we are committed to building training materials, self-organized, self-driven courses, and obviously documentation. So all that will come, although we need some patience for that.
Great, thank you.
Thank you, Mary. There was a question also about if the quantification of ecosystem service flow is done under the same operating platform. Stefano, Fer, can you take this floor from Siki soon?
Sorry, I was distracted for a second. Yeah. So if you expect
the question
me
was,
to speak.
Is the quantification of ecosystem service flow done on the same operating platform?
Yeah, I'm not sure what this means exactly, but whenever possible, we try for the models to have a explicit consideration of flows, and we always have, as Stefano I think has said, the two sides, the demand and the supply. So it's never just provision that we look at, which is a bias that has been long running in the ecosystem service community. It's always the two, and there's always a final output, which is the mix of the two. Now, the way ecosystem service flows is very different by service. So it can be either explicitly modeled, like in the case of water that you will see very soon. It can be modeled in an implicit aggregated way, like for example the recreation model, which works pixel by pixel, but actually includes accessibility, etc., and other things that are computed based on neighborhood effects. Or it could be completely irrelevant, like in the case of carbon, for example. The atmosphere mixes everything up, and it's kind of okay to look at it in a more global and aggregated way. So one of the big important things for Aries is to eventually be able to trace the flow effects of particular regions of interest. So, for example, you have a particular forest in your context, and you want to know the exact value of that particular forest, and maybe pair it to a particular set of beneficiaries, like a particular forest versus a particular city. How much the benefit does this city get from that forest? And maybe you need to have an entire watershed in that computation in order to do it right. So these things are coming, and we have a long-standing conceptual framework for that, using providers, beneficiary, transactors, etc. And we are now working on the model so that you can actually superimpose your idea of what those roles should be, because the system by itself doesn't know these things, because it's your own area of interest for each specific beneficiary, each specific transactors. But you should get, in the end, a quantification that is specific of those flows in those regions. So we definitely want to improve on the idea of how you do conceptualization, how you conceptualize ecosystem services by making it much more explicit. That it is indeed a process. It's not a stock. You don't have ecosystem services here because they are not there. They happen there, and that means that they evolve in time and that they are different in different places. So all these things will be part of Aries. One thing that you may have seen and maybe have wondered, I showed you an application. I showed you the General Explorer and then an application for natural capital accounting. So the question could be, where is the application for Aries? And it's not there yet because of these reasons, because we are actually still working on the very complex issues due to the fact that ecosystem services are actually flows. So eventually we'll be able to account for all these things appropriately and make it easy to run application.
But we are getting closer, especially when we include the hydrological models, and also there were questions about the marine part, and which we are missing. So I would say that with the hydrological models, process-based hydrological models, and the marine section a little bit more filled in, we are on the right track to do the Aries application.
Okay, so I think people might become a bit shy of speaking in a larger audience, and this is why we thought of splitting yourselves into 3 different rooms. Let me just post on the chat. So I have posted on the chat a website of my role where you can, in the splitting of the rooms, provide your inputs or your whatever you have to tell us, or even unmute yourself and we will write it there. But the idea now is that we will split into these 3 different rooms. Let me...
Marta?
Yes.
Sorry to interrupt, but perhaps Ferdinando could take Bruno's question, because I think that's a really important one. If we have another minute for...
which one?
Another minute for questions before we break into rooms.
Sure. So I'm reading it now. Can the system support having bindings that call available complex models coded in Python or R, potentially use machine learning libraries? Of course, yes. But it's, as I always say, integration is a two-way street. And we have a number of guidelines. We have done successfully this kind of integrations. It's never as simple as taking a model and putting it there, because that cannot happen. You have to work in a semantic system. And the most important part is that 90% of the code of running models that are actually implemented as scripts in a particular programming language go into input in data, forms or whatever, or just taking files, opening files, reading them, outputting stuff, visualization, unit conversion, they mandate particular resolutions, etc. In Aries, you've seen how we write the models. So very often, the first thing to do is to actually get to the core of what the algorithms are. And in many models, the algorithms and the core equations are like 2 or 3, and it takes like 1 afternoon to put them in Aries. So in those cases, we definitely advise to break them down enough that they can fit the semantics. In cases of complex models, there are several ways, and we have a little document that can actually explain that. The easiest way is to put them, make them available as web services. Not necessarily on the public web, they can be on a local machine, but that is an easy way, because if you make them speak the same language, it's basically through a network API. And at that point, the integration doesn't need to change anything in the model. You wrap the model in a web service, and then Aries reads it from there without any other changes. And then there are ways, like based on language adapters, that we will need to develop, at least for Python, for R, and this kind of things, where the model can be made to talk to k.LAB in an easier way. Sorry about saying k.LAB versus Aries. I know it's confusing. k.LAB is the technical infrastructure that runs Aries, and sometimes I get confused. So basically, those are the 3 main ways. But in general, it's a very different paradigm, and it usually pays to learn the paradigm enough to understand what models actually become once you consider them in this particular framework. Because in many situations, you realize that those models are not worth taking as they are and paying all that effort that it takes in order for them to actually talk to k.LAB is much easier to reconsider the logic. So we have ended up doing mostly that, but there are also other alternatives.
And there is also another question on riverine flow regulation and sediment regulation, and that's exactly pointing to what I was saying about the hydrological models, which are hopefully coming by the end of the year.
Okay, great. So as you can see in the slide here, these are the 3 rooms that we thought of splitting you into. You can select either room 1, which will be about ecosystem service community, so talking about if what the models we have suit you, the work you are doing suits you, etc. Room 2 will be dealing with Earth observation and actual modeling stuff. So if you're a modeler and you work with remote sensing, etc., this is your room. And room 3 is for dealing with questions on the business community. Some of you will actually like to develop an application, or will like to, or do actually have a business and we like to enter into contact with us to see how we can collaborate, Aries and yourself. So this is your room to be. We will be gathering your insights into this platform called Miro. So if you enter Miro, and if he asks you for a password, just ESP 2021, you can put the post-its yourselves. Otherwise, just feel free to unmute yourself when you are in the rooms, and we will write down whatever you are saying in the post-its. We are going to split into these rooms until 10 to 7. And at 10 to 7, don't click the leave button, because you will be automatically directed to the main room that we are right now, so that we can have a wrap-up of what has been said in the other rooms, hear them, and then just give a closure to this Aries webinar. Okay, so I'm going to, if you don't know where the breakup rooms are, they are just beneath the participants there. So you have 3 rooms, and I'm going to start the breakup rooms. You should see them now, room 1, room 2, room 3. Just feel free to go to the ones you want and stay there until we bring you back to this main street. See you there. If this has been interesting enough, we can repeat it somehow. The Miro will be still open for you to insert your inputs and send it to us if you didn't have the chance to take the floor. And now, just for room 1, room 2, and room 3, I will ask the moderators to give us a small wrap-up of what happened in the rooms, and then we will close the masterclass. So room 1, Zuzana, please.
Thanks, Marta. So just quickly, we were mainly talking about specific applications of Aries and whether there are specific cases or specific national scale applications that people could have a look at and like learn from how things were done. So we tried to make clear where that information can be found. And then we were going through the main requests that people had, and it seems that the major requests are for trainings and for additional like training materials. So we were noting those down, and we were flagging that the Miro board is going to stay open after this masterclass so that people can still keep entering their requests or like specific comments, and we'll collect it after the conference. So thanks.
Because I cannot speak anymore, sorry, I need Ferdinando to...
Yeah, well, we took a while in order to get the conversation started, and then we kind of went deeper into what the system and the paradigm of integrated modeling through semantics could mean for Earth observations, particularly. So I think we had some interesting point. Then a notice popped up that we were done. So that was a little bit frustrating because the conversation was becoming really interesting. But I think in the end, the message would be that for types of observations like Earth observations that are not meant to be used from design for a particular purpose, but are kind of in their own nature fitting a paradigm like a semantic paradigm and a network-based paradigm much better, it might eventually become very relevant to to have the ability of ingesting that kind of information, because it could automatically be part of many data and model pipelines that are at the moment denied because the human bottleneck in having to understand what comes from the satellites, for example, and deciding in which applications they could go to could really be bridged by an automated infrastructure like this. And that was the beginning of the conversation, and unfortunately there was no follow-up because it ended. But that's the gist of the conversation we had.
Ken, please.
Yeah, we had a very small discussion. We had 5 people in our room, and really the 2 points were about training and making sure that people can get it, which we know is probably our biggest bottleneck, and we hope to resolve in the months ahead. And then how businesses can use Aries, and again, stay tuned on that front. There's a lot of conversations that are happening with businesses on how we can, fairly grant use to businesses in a way that guarantees free use for nonprofit users, which we think is a core part of our philosophy. The last part I'll add was about data accessibility for the private sector, which may be an issue in certain cases. But that's more about the open versus closed data philosophy. So there's more we could touch on there, but again, we had just a little bit of time to do it.
Thank you. Yeah, I'm sure we could have stayed for 45 minutes, and maybe the next training we do, we leave more room for you to tell us how we can collaborate with you. Please feel free, as we say, to fill in your name and emails in the Miro to let us know where, if you would like to collaborate with us, in what, doing what, etc., etc. And as we have 14 minutes, this is the final countdown. I don't know what will happen. Just thank you all for your patience and your presence here. And we hope that the Aries team becomes your new family. Thank you.
Thank you.